So you mean 0/4?
Yeah.
Okay, which is 0.
for run. Sorry, say that again.
It's 0. Slope is 0.
Oh,
It
okay.
means, yeah.
So in that case, just 0. All right.
See.
So would I just say the same for B to C?
Yes. Yes, you want to go B to C, which is also 0/4, or it's 0. That's what you care about.
Mm-hmm. Okay. All right. Then 0, 0, 4/1, 4/1.
So this is all like work off the side. So now we can do a statement, reason, proof.
Mm-hmm.
This one's not that long. You're given like A, B, C, D is a quadrilateral,
It's a quadrilateral.
and that's given.
Mm-hmm. And then for 2, would I write the thing where it's like A, B, and then
I would write that B, C, or I'm sorry, A, B, I'm sorry. I guess you should calculate the slope. I guess that's probably what they want here. I would
Mhm.
probably say the slope of AB equals the slope of CD, which equals 4/1. And this is like definition of slope.
Definition of slope. So then with that, and then definition of slope.
So all we've done, Zach, and this is very important, is all we've done is say, here's what the slope is. The slope is 4. We're not doing any more than that.
Okay.
Now we are in the next one going to say that AB is parallel to CD.
Yeah. And then would I write like the y2 minus y1 over?
No, you would say definition of parallel lines. But it's actually the converse of that. We'll talk about that in a moment.
So then
So let's start with let's just go here. If I told you that 2 lines are parallel, what does that mean about the slopes?
That means that they're the same.
They're the same. Hang on just a second, Zach.
Oh, wait.
Okay, I'm back. So if the lines are parallel, the slopes are the same, right?
Mm-hmm.
So when you want to go backwards, it's called the converse.
It's called the converse.
Because we already know that the slopes are the same. See how we're going like the wrong direction? Like instead of saying the lines are parallel and then the slopes are the same, we're saying the slopes are the same and the lines are parallel. So that's the converse.
Mm-hmm. All right.
So whenever you go backwards, and you have to really think real hard about like which direction am I going? Is it that I'm starting with the lines are parallel and that means the slopes are the same? That's the definition. If I'm going backwards, it's the converse of the definition.
Yeah. All right. All right.
If that doesn't make any sense, we'll do a few more examples, but that's big deal here.
Okay.
Questions?
So is the converse basically just being like, oh, this is the same as this in a sense, like this is because of this, and it's just like a easier way to say it than like explaining it again?
Well, let me try to think of an example. Let's use another geometry example. If this is an equilateral triangle, what do you know about the sides?
They're all the same.
All sides congruent. if it's an equilateral triangle.
It's
Okay.
equal.
Now, let's say we start over here. Let's say I just tell you that AB is congruent to BC is congruent to CD. What does that tell you about the shape?
It tells you that it's a triangle.
What kind of triangle?
A isosceles.
Equilateral?
Oh, my bad. Equilateral. What's the difference with an isosceles to equilateral? Is isosceles?
Just two sides are the same.
Okay. Right. Equilateral, equal, all are equal.
So what I'm trying to say is Zach, is like if I tell you something, if I say it's an equilateral triangle, then all sides are congruent. But if I just tell you that all sides are congruent and you want to go backwards to a triangle, that's where you have to use the converse.
Okay.
Trying to think of a better example.
So all sides congruent. Okay. Yeah, this is. I think I get this.
Okay, so let's do just a more like literal one. So if it rains, fill in the blank, then what happens?
Water will hit the ground.
So the courts are wet.
Mm-hmm.
Okay. Now let's just say you were inside a building and you found out that you walked outside and the courts are wet. What can you then conclude?
That it rained.
It rained.
Okay.
That's the converse.
Mm-hmm.
But you're going backwards. Like you know, like it's better. Like it's better in our problem if we already know that the lines are parallel, but they're not. You're proving that they're parallel. You prove that they're parallel because the slopes are the same. The slopes are the same, but the way you use the parallel leads to slopes are the same. So when you go backwards, it's the converse.
Okay. All right. Yeah, I think I get that now. It's like you're
Okay.
using your answer
Yes.
from the problem to solve like explain better. I get this now, but
Okay,
yeah, it's
good.
kind of tricky to explain in your own words. Okay, yeah, I actually do have another question.
So we're not quite done with this, but yeah, jump in with your question at any time.
Um, so it's not exactly relating to this, but when there's could we go after or go over after this one the problem where you have like here, let me get the exact name for it, but it's like I call it the spider web where it's got like all these angles and you have to say like what the angle is.
Okay.
Like
Sure.
I'm trying to remember the names for it right now. I'm going through my notes, trying to find it so it's more specific. But where you're using like a, I guess, alternate interior or something like that, like using those kind of angles to figure out.
Sure.
Thank you.
Yeah. Okay, now we're not quite done with this problem because we've only shown that it's got one set of parallel sides.
Uh-huh.
You need to show that it has two. So there's a couple of ways you can do it. You can actually you could sneak it into step 2, but we'll just make it step 4. Slope from AD equals the slope from B to C, which equals 0. And that's the definition of slope formula, or using the slope formula.
Okay.
Okay, and then 5 here, 5 is just like 3. It's that AD is parallel to DC. But again, it's because of the converse of the definition of parallel lines.
I like that, like the converse thing. It's a good way to do less work in a sense.
Generally, you use converse when you trying to prove something is a thing you already know it to be visually. When you think it's like, you're like, well, it's already a triangle, it's already a parallelogram. You're like, all right, I'm gonna use converse.
Yeah, I like that. I'm gonna have to use that.
And then what's frustrating here is you're still not done, because you still have to say that A, B, C, D is a parallelogram. And the reason is, well, if it was a parallelogram, what would you know about the sides? What would you be able to say about the sides? 3 and 5.
That they'd all be the same.
Parallel. We used parallel. So if this was a parallelogram, what would you already know about the two sides?
They have two pairs of
Parallel sides, right?
yeah.
But we don't know that it's a parallelogram. So because we're going backwards, we say the converse of the definition of a parallelogram.
The converse of a parallelogram. All right, yeah, that's pretty efficient.
Yeah.
Okay, so I guess you could use that for these problems a lot.
Yeah, I mean, it's almost like if you went backwards. If you said, all right, I'm given that it's a parallelogram. All right, that's given. If it's a parallelogram, then you know that AD is parallel to DC. Why? Because it's a parallelogram. Definition of a parallelogram. Well, why are the slopes the same? Because parallel lines have the same slope. Okay, like you're going, like you can almost go backwards to get to the where you started.
Mm-hmm.
Okay, now you mentioned a spider web problem. I want to make sure I like this is the standard problem. Are you talking about something more than this?
Yeah, where it's got like a lot more of the like lines all connecting to each other.
Okay. Yeah, let me go find
What's the
a
name for that again? Because I've
say that
like
again.
problems.
Say that one more time.
Oh, what's the name for like a problem like that?
These are two parallel lines cut by a transversal.
Okay, thank you. Because that's what I was trying to like remember that whole time, and I was just like, oh, it's like almost there.
Two parallel lines cut by a transversal. Okay. Okay, so let's go a challenging angle transversal problem.
All right.
All right, here's one. All right, so we talked about this a little bit last time. You do want to try and do them in order.
Mm-hmm. Yeah, that really helps out.
Yeah, and they're designed to be done in order, because the person who makes this is just like you and me. They're human, they like order, and they're not trying to make your life more difficult.
Yeah.
So sometimes the hardest thing is just to figure out, like, where is A or where is the first one.
Yeah.
So what we should do here is you should tell me letter A, but more importantly is the reason behind it.
A is vertical and 64 degrees.
I agree.
All right.
How
I
about B?
remembered some of it. Let's go. All right. So B is um 132 alternate interior.
Nope. It's a linear pair.
Linear pair. Oh, is that where it's just side by side?
Yes, when they're next to each other, it's either a linear pair that way or that way. Either
Okay.
one doesn't
So
really
would
matter.
that also be 64 degrees?
No, the linear pairs add up. You're seeing my screen, right?
Yeah.
Linear pairs add up to 180.
Is that where you're using two numbers on the line where it's the line? So it's like a 180-degree line, and then there's a line going up.
Yeah, so I mean, depending on your viewpoint, it's like this. This is 64 and this is B.
Okay, yeah. That's what I was wondering. Okay, so linear pair can be just side by side. And then that would just be
You got to be able to solve here. You got to be able to subtract both sides.
oh, sorry, I was not looking at that right. Yeah, that would be 1/16.
Yes, B equals 116.
Yeah, I was trying to do some like crazy math there. That would not work out.
Okay, now be very careful about C and D, I guess, for that matter. You are using the fact that they're parallel lines.
Uh-huh. So they're parallel lines. C, D. Could I say that D is would saying an exterior angle, is that a thing?
It is, I mean, I wouldn't go right to that. I guess I would do D first by corresponding.
Corresponding. Okay.
I find that's easier than trying to go like, let's like jumping over two things.
Yeah. Okay, that's true. So corresponding
Corresponding means they are equal.
64 degrees.
Yes, D is 64. Now to find C, you have some options. You can use the linear pair.
Mm-hmm.
Okay, now to find C before D, you would have to like use vertical angles and then use corresponding.
Yeah. Could I say vertical for
No,
this one?
no,
All right.
no.
So why would vertical not work just since that's like what I naturally went to?
So let me zoom in on the thing that we're doing here. Let me just try to get it on the other screen so I can see it to draw it. So let's just zoom in, really zooming in here. Here's what we have. We found 64, 64, 116, and then we were trying to find C. Okay.
Uh-huh.
So the angle vertical to C is right there. That's vertical.
Yeah.
We don't have that one.
Oh, so it's just non-existent.
Yeah, that's 116.
So
Okay, now
there's
alternate interior gives you 64 and 116. Then you can use vertical,
Mhm.
but not the way, like think of a proof. A proof is like 116, and then I get this other 116, that's vertical angles.
So
Then I
can I
put it
say
here, alternate
it's
interior
alternate
angles,
interior and
then
then
vertical.
vertical?
Yeah,
Okay. So to do vertical, I'd have to do like two steps before it essentially.
yes,
Okay. And then something that could make more sense would just be corresponding.
yes.
And then corresponding is where one's on the interior and one's on the exterior, but they're not next to each other.
Um, wow. I have to think about that, Zach. Give me a lot to think about here later tonight. C and 116 are corresponding.
Uh-huh.
Um, I guess I think of it differently. If you like that, you said because they're on the same side, they're
Uh-huh.
just not in the same, one's in the exterior and one's in the interior. That is true.
All right. How would you do the definition for it? So I don't.
So when I first moved to Tucson, I came from a place where roads were not constructed in 90-degree angles. I just
Uh-huh.
couldn't believe it. I'm like, well, this is the most amazing thing ever. They're constructed at 90-degree angles. And I was like, wow, there's always a Circle K, like on the northeast corner, there's a Circle K.
Uh-huh.
And that's how I remember. Like, I'm like, oh yeah, on that other one, it's also a Circle K in the northeast corner. Now, whether that's true or not now, I don't know, but that was my perception of reality. It was like, and these are corresponding
Uh-huh.
because they're always in the same relative position. Like if you're standing right there and you're standing right there,
It'll
it's like
always be
where
on your right.
it's always in that top right or top left, and so on.
Mm-hmm. So it's always there.
Yeah.
Okay.
something like that. I guess I always, to me, that's what corresponding meant, is it's like, it's, you could like, and so there, okay, you probably haven't seen this movie, but there's the movie about the Apollo mission where the astronaut, the thing exploded in space and they had to get the astronauts back.
Uh-huh.
Right. So the engineers in Houston, they had to get a box of stuff that replicated what the astronauts had, and they had to like explain to them how to do it, but they could only talk.
Yeah.
So imagine like I'm talking to you, but you can't see my screen, and I say, grab this rectangular piece of material, and you're gonna go to the top left corner, and you're gonna attach a thing to it. And
Mhm.
so like it's like all relative. Like you have to hold it a certain way, and you have to know like top left is really the top left.
Uh-huh.
And that's what corresponding is. Like everything corresponds to the same thing, same relative position.
Okay. All right. Thank you. Yeah. Okay.
Okay. So okay, let's use this better example. Sorry, I always sometimes I forget you play tennis. This is a way better example here. Okay. This will make way
No,
more
I think
sense
like
when
that
we're
one
done.
better.
Okay. Where do you want to serve? You want to be on the top or the bottom here?
I'll do bottom.
Okay. Do you start serving from the right or the left side?
On the right side.
Okay, so you're over here serving. Where is Matthew when he's returning serve?
It's gonna be on the left side.
But from my perspective, where is it?
Um, the right side.
That's right. That's the corresponding side. So from my side, it's the right side. From your side, it's the right side. It corresponds.
Mhm.
When you move to the left side, I also move to the left side. See how it's
Right,
always
and then it looks
corresponding?
like we're running to the right for each other.
Yes. If you're, you because it's corresponding.
Yeah. Okay. All right. I
Okay.
get that. It's like
Okay,
the
so but
same
the
thing.
the differences with parallel lines is you're not like looking down versus up. You're just you're in a relative position. Top right, top right, top left, top left.
Yeah. Okay. All right.
Okay,
Yeah.
let's go back to this problem. Okay, so now we're going to switch our attention to E, letter E. So
Okay. Letter
here's
E
E.
is vertical to 108 degrees.
Yes, 108 degrees, vertical angles. I agree.
Okay. And then
How about letter F?
F is, oh, what's the name? 72 degrees
Okay,
and shoot, parallel. I'm just gonna take the guess on that.
okay, linear pair.
Linear pair, okay. Linear pair. All right, I'm writing that down too.
Good. I mean, good effort. You're throwing out at least a geometry word. That's better
Yeah.
than.
We're getting there.
It's like social studies that you'll throw out a country. It's like just like, look, that country didn't exist, and we're studying, World War I. It was the Ottoman Empire, not, you know, modern day whatever we got. So yeah,
Yeah, no Bosnia.
yeah, and I mean, in your lifetime, there's been some changes in countries, so it does happen.
Yeah. And
But
I
yeah,
guess
you got
for you, like, one day you wake up as someone in that country, and then the next day everything's different.
Well, if that happened, if we ever had to experience that, I mean, I think that's pretty overwhelming to think like, no, now I'm a different citizen of a different country. I think you'd see a lot of unrest if that were
Oh
the
yeah.
case.
Yeah, that would really not be fun.
Yeah. Okay. So linear pair in linear pair, the word you got pair means two, right?
Mhm.
Two of them. I got a pair of socks. I got two of them. Okay. Linear, that doesn't really help much, but pair, think of it as two angles adding up to something. Okay.
Okay. All right, yeah, linear adding up to 2. Okay.
Now our next letter here is H, letter H, but you can do G first if you prefer.
Um, okay, I mean, I guess. Um,
So if you
is it
could,
possible to go from exterior and exterior?
yes, but you don't have to in this one.
Okay, but what would that be called if you did?
The exterior angle theorem.
Okay.
But you're
Um,
you're you're doing that using vertical angles, alternate interior, and then vertical angles again.
yeah. Okay.
I want you to
I
use
guess
corresponding.
could you say I'm solving for H, you said?
Or I would do G first.
G.
G is more clear
Oh,
based
right,
on
yeah, that's the alphabet, yeah. All right, yeah. Could you say a so you want to okay, so you'd want to use the 108 degrees on the interior,
yes.
and
Yes. Now,
then
like if you look back here, we said that D is 64. Do you remember what the reason was for that?
because it is a linear pair.
No,
Mm.
corresponding.
Um, correspond.
Corresponding.
Right. Oh, right. Right, yeah, that's on the inside. G's on the outside.
Same side, one's in the interior, one's in the exterior.
Yeah, okay.
What is the value of G? It's very much
G
related.
72, no, 108 degrees.
They're corresponding again.
Corresponding is the same thing. And then the vertical angle would it be
So if you're going vertical angle, that's over here.
108? Yeah.
We
And
don't
then
want that one. We don't care about that one. There's no
right.
letter there.
Would I say linear pair 72 degrees?
Yes, yes, yes.
Okay. Linear pair.
I mean, I think I can see what you're trying to do, which is you're trying to like um somehow like remember like, okay, if it's same side, interior, exterior, don't recommend that. I mean,
Yeah,
it
not
may
the
sound like it works initially, but
once it gets more complex, that's not the way to do
yeah,
it.
yeah, you're gonna really struggle there. So let me snip in this picture again, and I'll write in the ones that we need for moving on here. So this is 108. This is 72. So now we're going to I and J. I and J.
Okay, so
And if it's not clear, I'll do it in green here. Parallel and parallel.
all right, thank you. Okay, I is corresponding with 108 degrees.
Yes, very
And
good.
then J is vertical to I, also 108 degrees.
Very good. Since we're here, let's do S and K.
Then K is corresponding 108.
Okay, I agree.
And then linear pair for S 72.
Very good. Okay, so we found K. Sometimes they skip a letter, like where's L? I don't know, but we can go to M. M is next.
All right. Um, just trying to turn my head the right direction to see it. um,
So whenever you see two things right next to each other, that's a
that means they're the linear pair.
yes.
So linear pair. Um, it would just have to be 105 for M.
M is 105. Good.
And then
Now we
if
go
I
to
say
N.
N would be all it's like I just want to say vertical with 79
Yeah,
degrees.
that's it. That's it. They're vertical.
Oh, okay. I can do that.
Yeah.
Okay. All right. Yeah. I
Vertical
guess
doesn't
vertical.
require anything to be parallel.
Yeah. Okay. And then, um, sorry, what letter was that? N?
N.
Okay. Um, M, N, L. OP, but it doesn't look like they have that either. So should I just go on to P?
P sounds good.
Okay. So I do have a question for P. So I want to say linear pair,
Okay,
but
it
there's
is,
a 90-degree angle.
that's okay.
So then would I
It's a
just
lit,
say
it's a,
it's 90 degrees or
yes, P is 90 degrees.
okay. And then yeah, okay. Sweet.
So
Easy.
Q is kind of a hard one here to determine. I want to drop this image in one more time so that I can help you figure it out. Okay, so we're up to Q, and your attention needs to be on this thing right here, because Q is also right here. Why is Q also right there? What's the reason for that?
It is a vertical angle.
Vertical angle. And then 75 is really right there
75.
by also by vertical angles. I know
Right,
it's
yeah,
hard to say.
vertical.
Okay. Now in a, and I don't think you've covered this in your class, but it's not that unreasonable to ask. In a four-sided and a quadrilateral, the interior angles add up to 360.
Uh-huh.
So you have 90 plus 79 plus 45 plus Q equals 360.
So for when it's a sorry, is that a rhombus?
No, it's just a quadrilateral.
Okay. Oh right, yeah.
Quadrilateral is four sides, maybe just four sides. Rhombus is down the parallelogram.
Right, yeah.
Right.
So then I guess you just make it 169 plus 45. 169.
I'm sorry, that's 75. I wrote that wrong.
Oh, all good. 169 plus 75. 14. 11, 2, 214 minus 360. 6. 46. Q equals 46.
Sure.
And then.
So that takes us care of that. And then you
So
go.
can I call that? I can't call that an alternate interior though.
No, it's just that angle, and then it's vertical to Q.
Okay. So it's just. Okay. All right. It's just that number. But I have to write like any words along with that?
No, you're just given a number. Your instructor's going to look for the work that's reasonable.
All right.
Sometimes there's no work.
Yeah, no work, no right answer.
Okay, now we're over here to T, I believe. Last one.
Okay, so then with T, you can say it's a linear pair with 61, making it 119.
Yes, T is 119 degrees.
And is that a linear pair?
Yes.
Okay, cool. All right, yeah, this is a lot easier than the first time I was doing all this.
Yeah.
I guess that's the way it's supposed to go.
What should we do from here? We've got 10 minutes left, Zach.
All right. I guess. Let me look at those papers, just because it's the unit summative. All right, wait. I do have a question. So on one of the last images I sent you, it says 4, 5, 6, and then use the properties from question 4 to answer the following. And it's PQRS is a rectangle and OS equals 16, and it has those shapes with it. Where they're it's like what you're.
Oh yeah. Okay. Yeah, I got it. I'm sorry. It just took me a moment to get to that.
I think I'd like to go over those. Like I think I know how to do them. I'm not like super positive.
Sure. Okay, PQRS is a rectangle. So sometimes they give you, stuff you don't really want or need, but in this
Oh,
case, they're telling you O to S is 16.
O to S is 16.
Yeah.
So then, oh wait, would they just all be 16?
Well, yes, that's because it's a rectangle.
Uh-huh. So that one's like a no-brainer.
Yeah. Now from P to R, it's 16 and 16, which is 32.
So then 32. So would I have to, so for MQRS,
So let's look at which angle that is. It's Q to R to S. So it's this one up here.
mhm,
What do you know about the angles in a rectangle? What are they all?
90 degrees.
They're all 90 degrees. So it's kind of like earlier when I was asking, like, okay, what is it? Is it a linear pair? Is it vertical angles? Like, you got to sometimes think like, well, it's got to be something I'm supposed to know, like 90 or 90.
Uh-huh.
A lot of them are 90.
Okay, all right. So the rectangle one's like probably one of the most simple, I'm assuming.
Yeah, we can go through number 2.
All right. What is it called when all those lines are going to the middle like that in the X?
They're diagonals. The diagonals are go from the opposite vertices.
Okay. All right. Diagonals from opposite vertices.
Okay, so KLMN is a square, and N to M is 8.
8. Okay, so then every single side would be 8.
That's right. So the perimeter, I think you were asking about that earlier, is 8 plus 8 plus 8 plus 8, which is 32.
All right, 32. Um,
Okay, now the measure of angle OKL, well, that's kind of hard. Let's do, oh, I see. They also want you to do this. Okay, so in a square, the diagonals meet at 90-degree angles.
diagonals meet at 90-degree angles.
Yeah. That's how you answer OKL, and because that's this one, and then MOL. They're just 90.
Yeah, just gotta add them all together.
Yes.
Um, okay. Shoot, yeah, I guess whenever it's
Let's do another one here.
I hope they just give me a square on the test, to be honest.
You shouldn't count on that. You should count
Yeah.
on the one that's more difficult.
The most tricky ones are the one you should study for.
Yeah, should not hope. We should just know
Yeah,
how to do them all.
hoping is a risky thing.
Yeah. Okay, ABCD is a rhombus. AD is 11. D to O is 6.
Yeah, so then
So what is B to C?
um it is
A rhombus shares a
11.
lot of properties with squares.
I think it's also 11.
It's also 11. I always think of a rhombus as a square that's been pushed over.
That's a good way to think of it. I always think of it as like a kite that's
No, that's very bad. Do not. No,
yeah, or I think of
that's like
like
calling a
a
dog a cat. You can't do that.
kite.
Or a cat a dog. It's bad.
Yeah, or
But
I'm like, oh, it's like a kite that's not, you know,
yeah,
broken.
no, that's really bad. Don't do that. But
Okay.
so the other sides are 11 as well.
Okay, 11, 11, 11.
Right.
And
Now,
then 6,
I
6,
think I
6.
sent you a reference sheet from last time
Yeah,
about these. Let me see if I can pull that up again. I'll snip in the relevant stuff here, because the because the properties are really important to know. I don't want this one, I want the other one.
So 11, 11, 11.
All right, here we go. Snip this in. All right, here we go. All sides are congruent, so we already dealt with that. Diagonals are perpendicular. That's super important here, just like a square. Diagonals are perpendicular.
Diagonals are perpendicular.
So that helps us answer the angle of AOD.
90.
Now, the last one's really, important here, that the diagonals bisect each other. So what that means, and actually I probably should start fresh with the picture because there's a lot going on. So let me go over here. So it means that this and these are congruent, and then the other two parts of the diagonal are congruent, but they're not the same. They're not all the same.
They're not all the same.
And if you think about it, like if you push over a square, it's going to be longer from one diagonal to another than from the diagonals.
That's
So,
true.
but in O to B is 6. Like that's okay because they're the same.
So
But then you're like, well, how do I find? Well, B to C is 11. How do I find O to C? I guess your instructor added that for some reason. So O to C is, draw this triangle. Here's O, here's C, here's B. 6, 11. How do you find the hypotenuse? I'm sorry, the leg of a triangle?
You know what it equals to.
Pythagorean theorem.
Pythagorean theorem.
A squared plus B squared equals C squared. So you have 6 squared plus B squared equals 11 squared. 36 plus B squared equals 121. Subtract B squared equals 85. B equals the square root of 85. And that's this one here. Sometimes it's nice, sometimes it's not. This one is not nice.
So in order to figure out the A to C. Sorry, wait. What were the numbers for that one? I mean letters.
O to C.
O to C.
Yeah.
So okay. Right, because the thing's not 6. It's bigger than 6.
That's right.
And then okay, yeah. Boom, boom, boom. And then I guess would I have to make like labels on the shape as well, such as like on the rhombus?
No, I mean you just have to mark the answers. I mean, I'm just trying to help you out here with them.
Yeah, of course.
So that's it here. Definitely recommend reviewing the video we said over the weekend. Do have some times on Sunday still available and Monday as well if you want to get a last session in before your test.
All right, awesome. I might need to consider.
There's definitely more stuff we could have gone over tonight that we didn't cover on the sheet. But that is it, Zach. Thank you for letting me help you, and hope you have a great rest of your night. I know it's late, but you'll
you too.
get your math workout in for the day, and I'll see you tomorrow, or see you next time. Maybe not
Yeah,
tomorrow.
all right. I'll
Okay.
see you, Matthew. Thank you.
Okay, bye now.